Hi, so moving along down the FSL pipeline, we today are going to focus on getting our functional data prepared. So far you should already have your structural data all set, and you should have already had a peek at your functional data to see how they looked. So we're right here on, we're right here on the, in the pipeline. So you've already converted your DICOMs to Nifty. I will put a link here to a blog post where you can get some tips on that. And hopefully you've already skull stripped your structural images and run the QA step. I will also put a link here to the video that covered that. So the things we're going to focus on with our functional data are trimming the volumes off from the beginning. So this is going to vary scanner to scanner and even protocol to protocol. It depends on what you do at the scanner. So if you forgot, you need to backtrack and figure that out and maybe double check with whoever helps you run your scanner what you need to do. So for example, even at UT, the same people using, or different people using the same scanner, some had to trim 5 volumes and some didn't have to trim any. Also, we're going to fix orientation issues just as we had to with the structural images. In fact, it's the same command, but I'm going to show you an alternate command just so you can see an illustration of how it's used. And most importantly, I'm going to show you a way of assessing the motion. And then this kind of all really is a QA step, but the QA here is to actually look at your data, especially after fixing the orientation issues and looking at the output from the motion assessment. We'll get there. So as I just said, the code I'm going to show you is going to trim 5 volumes. I actually have it commented out because I didn't need to do it. If you're using the OpenFMRI data, you won't need to do this step. Right, and again, revisit your scanning acquisition protocol. And also what you need to be careful is that your time 0 for your behavioral onset files matches with time 0 for your data. So go over that a few times and make sure you have that straight. So here's why you want to trim volume. So take a look at this. This is the first TR and compare it to the 4th TR. See how much brighter the first TR is? That's because the scanner was still warming up. Interesting factoid. So with resting state data, they're actually showing that this scanner warm-up artifact lasts a lot longer than we thought it did. But anyway, that's another day. So typically it's like from 0 to 5 volumes. Okay, so speaking of onset timing files, if you're not using the OpenFMRI data, you're going to need to make these. So if you used, If you use MATLAB to collect your button box information or to deliver your stimuli or both, then you'll need to get the output from that and process that into we're typically going to use a 3-column onset format, where the first column is onset time in seconds, the second column is the trial duration in seconds, and the third column is parametric modulation. I'm willing to bet most of you will have all ones for the parametric modulation. If you don't know what that is, then I think I have a video on it. I will link to that video here if it does in fact exist. But an example of parametric modulation would be if you had a gambling task and there was an amount that could be won or lost for each gamble, you might have a hypothesis that the bold activation magnitude will fluctuate according to the gamble amount. And this is how you would model it. So I'll link to the video there. And we'll look at an example of an onset file when we move away from the PowerPoint slides. Okay, so you also want to fix orientation issues. So we already covered this for the structural data, so it should be easy because it is the same process. You want to load your data and view them and check that the axis labels are correct. So they're going to be missing from the OpenFMRI data. I'll check into why this is the case, but it's okay. You can assume they're fine and the data should analyze perfectly fine because I've used them in the past. So yes, again, with the OpenFMRI data, the axis labels will be missing. But just assume that they're okay. But for your data, they should be there. And if they're not, you should figure out why they're not there. Because otherwise you have no way of verifying on your own data if right and left are in the right place. So this is a time to do that too. If you taped a vitamin E capsule or something like that, or taped something to the goggles on your structurals to indicate right from left, Now double check, you have to open your structural in one viewer, your bold data in another. And it's kind of hard. Obviously, the slice acquisition is different, or the thickness of the slices and things like that. But do your best to verify you don't have a right-left swap or something like that. But the vitamin E capsule won't show up on your bold data. If your axes are properly located, you can just use the FSL reorient to STD, and that will fix it. I'm going to show you an option with FSL swapped in, since I had mentioned it before. Okay, assessing motion. So this is the biggest part, because this will actually, well, everything will have an impact on your analysis, but this could have a big impact, especially if you're scanning subjects who are either really young or really old. And for really old, I don't know, I'd probably say over 50. Any age where motion will get worse in the scanner. So there isn't an approach that's generally agreed upon as being best. So keep in mind this is being recorded in what are we, January, February of 2016. So if it's 2017 even, you'll want to revisit the literature on this because it is changing that quickly. But you need to do something for motion. The most standard thing that's been done in the past is to put just the motion parameters, and we'll get there. We're going to do that in one of the next videos. But it turns out that they're finding that that's not enough, that we need to do more to address motion. It's less of an issue in task fMRI, but if you have these populations that move around more, then you should take it a little more seriously. So the two options are motion scrubbing, where you basically delete bad time points via the general linear model. And the other way is using FSL's ICA-based fix algorithm and other similar ICA-based algorithms. I know that Christian Beckman has another one. The name is failing to come to my brain right now, but it is also supposed to work really well. And what this is a semi-automated noise component selection tool. So you take a few subjects, you run them through ICA, and you mark their bad components. And then at least FSL's fix uses a machine learning algorithm to go through the rest of your subjects and mark their bad components. And then you take the time series from those and put them in your model. I'll do a separate video on this because I have really wanted to take fix for a drive because I haven't used it yet. But that will be later on. We're going to use motion scrubbing. And again, nobody agrees which one of these is better. And I haven't seen anything that's super convincing one way or the other. Basically anyway. But if you do something, it's better than nothing. Okay, so the FSL functions I used in today's script, and I'll show you the script in a second. FSL swapped in, again, you can just use FSL reorient to STD, but I'm just adding this to illustrate the usage. FSL ROI can be used to trim in any dimension. So we're using it to trim along the time dimension, and this is how you chop off your extra volumes. And FSL motion outliers is what we're going to use to do the scrubbing. It will create a file that we can just dump into our first level model when we get there. We're almost there. Okay, so let's look at the script, but before we get to the script, I want to show you the onset files. So let's go there. Uh-oh. Now, Picasso, you're going to keep jumping there. Okay. Two things. So this is the output from an onset file. So this first column is the onset time in seconds. Next to it's the duration. So, there was a trial that occurred at 3, 6, and 8.5 seconds. And each of the trials was 1.5 seconds long. Okay, and then there's no parametric modulation, so the third column has all ones. Now these onset files are, again, they're from the OpenFMRI data that I'm using. And you'll see they're just called COND 1, 2, 3, and 4. But if you go to the Model 001 condition key file, it explains what these are. So COND 1, and FYI, I'm only going to analyze task 1 in these videos. COND 1 is go, COND 2 is successful stop, COND 3 is failed stop, and COND 4 is junk. So these are trials where things were just messed up. So I bet you don't always have a COND 4 file. I bet some subjects won't have a COND 4 file. So we're going to tackle that problem when we get there. So, okay, that's what you need to do. If you're not using the OpenFMRI data, you need to create your own onset time files. And FYI, I would actually put more descriptive labels. I would actually call it go.txt, successful stop.txt. I think that would be easier for your own retracing your steps in the future. Just a personal preference. Okay, so that's the onset files. Get those ready. The script. So this script is in the Dropbox. I will put a link to it in the description bar below. And I'm using Python again, so this line will make it executable from the command line. You can just put the name of the script. You don't have to type Python before it or anything. I'm going to be using glob, os, sys, and subprocess. This path, you will want to change this to your path. So this is the DSO08 directory. So if you're using those data, you'll just change that to yours. So glob we used before, so awesome. It's basically going and grabbing all the bold files. So again, I'm only analyzing task 1 data, so I didn't put a wildcard in here. I only put a wildcard in for the run. And if we look at bold files, I have it loaded up. It is just a list of all my bold files. Super handy. And how many are there? 41. Okay, so those are my bold files. So the first thing I'm going to do, and then there's this HTML. So I'm putting all of the sort of QA information from this into an HTML file because it's really easy to add text and figures to it, which is exactly what I'm going to be doing. If you have a better way of doing this, because I will tell you, an issue with the HTML files, you can't move the file itself. So, okay, I use a machine remotely for most of my analyses. For these, I'm using my laptop. But if I remotely create this HTML file, the only way to look at a big HTML file remotely, it's very painful. It takes forever to load. So I typically try to print it to PDF and then I move the PDF to my computer because otherwise the images won't load. But even that, for the system I'm currently using for some reason, it can't handle that either. So if somebody has a better way to do this, a way to put PNG files and text together that's not an HTML, you let me know. I'm not going to get picky. I don't think I could directly make a PDF, but maybe. But this will work. This will work from now. It's worked everywhere else I've worked. It just doesn't work on the computing system I'm using here at Wisconsin. I'm also going to create this out bad bold list. So this is based on the scrubbing. If we find too many bad volumes, probably want to throw a subject out or at least be alerted. Okay, so just in case I run the script more than once, since both of these files are created by appending onto the end of the file, I start by deleting. Otherwise, you want to create a script so if you run it twice, it doesn't keep appending to the old stuff. Okay, so then I have a loop that goes through all the bold files, prints which bold file it's on, and it sets the current directory. So now the bold file name, as I just showed, has the bold file name in it. So I actually want this path to do other things. So that's what this does, is it just strips that path off. I also want to strip off the .nii.gz. So if you don't have zipped up files, this will fail. If you just have .nii files, you need to adjust this. So mine is 7 because I have 1, 2, 3, 4, 5, 6, 7 things to trim off of it. So this is going to trim everything off that path except for the .nii.gz, and that is so I can create new files and create the file names more easily. Okay, so I have a lot of all caps. It's me gently, not yelling, but notifying you that don't just run this code because it's here. Okay, this is the part where you can also use FSL reorient to std, which is what I showed you last time. And it's this FSL swapped in command temporarily. So what it does is there's an input file, which is the cur bold with no NII, and it replaces So these three slots stand for the new X, the new Y, and the new Z. So basically the old Z becomes the new X, the old X flipped becomes the new Y, and the old Y flipped becomes the new Z. You get the hang of it when you do this enough. This will have the same effect. I'm only showing you in case for some reason FSL reorient to STD fails, this will work. Actually, I think FSL reorient to STD will almost always work, unless you just have things totally wrong, and then even FSL swap dim won't work. And FSL swap dim does have built-in things to help prevent you from doing a right-left swap. You'll notice here, excuse me, that I have changed the name of the output file. You don't want to have, you could end up with 3 copies of your bold data by the end of the script, and that's probably not good in terms of your disk space usage. So I would run these commands individually on a single file until you're 100% sure it's doing exactly what you want to do, and then boldly overwrite your bold file each time. You can always get your bold file back from your DICOMs. It's just not, it takes some time to do that. So anyway, once you're confident, delete this part. If you're not, keep it in there. But I would be pretty upset if I was the person paying for your disk space and I found out you're creating 4 copies of a single file. Okay. Next, again, don't use this unless you've double-checked how many volumes you need to trim. So for those of us using the OpenFMRI data, you don't need to trim any volumes. This is trimming 2. Basically, I put the input file name, which if you are inputting the swapped one, you're going to have to edit this to put swapped. But again, you should get this working until you're positive and be okay with overwriting the bold, in which case feeding in the bold, cur bold, no NII, will be fine. And then this will create a trimmed one. Again, once you're sure it's doing the right thing, I would delete this trimmed and run it like this so that you actually overwrite your original file. Okay, FSL ROI, let's look at the usage. Okay, forgetting how to use my computer. Here we go. FSL ROI, input, output, X-min, X-size. So this is if you want to trim the data in the X, Y, and Z direction. But we actually want to trim off time points. So you put in tmin. Annoyingly, FSL always starts counting from 0, except apparently for here. So tmin is the TR you want to start at, and then T size is how big you want it to be. It turns out to be true that if you just make T size bigger than how many time points you could possibly have, it'll just stop when it hits the end. So since I have variable time points on these bold data, I think, I just set it to, well, and I don't need to run it, but 300, you can just set it to a number that's definitely far bigger. So this will trim the first 2 TRs. It's starting at the second, and it goes on. Okay, so play around with that again at the command line until you're confident it's doing what you want. Then I'm making a motion assessment. Everybody's going to run this, that's why it's not commented out. I'm going to create a directory called motion assess. So first it checks if it exists, and then it just creates the directory. And then FSL motion outliers is run. So let's look at the usage for that. So you just type the name and hit enter, and you get the help. Let's make the window bigger. Okay, so you do the input file. This will be our bold data. The output confound file, that will be a text file, and then options. So there are lots of options. The options we use are, first of all, we're going to use the FD, which is a frame-wise displacement. I'm going to do another video that goes over FD and DVARs. I'm not sure, I'm going to base it on a paper, maybe the paper I'm about to show you. So I want to use FD, and I also don't want to use the defaults for the threshold, so I'm going to set the threshold to a value. So FD is a frame-wise displacement, is what it stands for, and it's a way of summarizing how bad the motion is. Now you'll see I put a link here. So I'm using a threshold of 0.9, and it comes from this paper, which is specific for task fMRI. If you're using resting state fMRI, they recommend a much lower threshold. Again, moving target, this could change a year from now. So here's the call. Input file, this %s gets filled with the curve bold no NII. Again, if you're not inputting the bold.nii.gz, if it's one of these bold trimmed or something else, you have to put that in here. The output is going to go into this %s gets filled in with the directory, and then it goes to the motion assessment directory that we just created and a confound.txt file. What this is basically something that we can put into our design matrix. It's a column for each, so let's say we have 3 volumes that need to be scrubbed. It will create a column for each volume that's all zeros and a 1 for that volume. So if I have 3 volumes that need to be scrubbed, I will have 3 columns that are all zeros, but just with a single 1 in each column indicating which TR needs to be removed. Okay, and here's where I'm telling it to use FD with a threshold of 0.9. I'm asking it to output the plot, put it in the motion assessment directory, and it's going to be called FD plot. And -v, what is -v? I think that's verbose, and I think we're actually, I actually don't need that. I don't think it's doing anything. Oh, no, it is. Yes, this is cool. So I ran it in verbose mode, and that spits out a bunch of information. And I'm going to put that information into a text file called outlier output. Notice this is different than confound.txt. And this is what I'm going to put into the HTML file later. Again, I would recommend running all of these just at the command line so you can see what they do, and then run the Python script. Okay. Whoops, this should not be commented out. So then we put the confound information into an HTML file to review later on. So I'm going to first dump in the outlier output information. That'll be at the top. Then I put a line, and then I put the FD plot is going to be in there too. So 2 things, this outlier output and FD plot. The only output from this line that we're not looking at here is this confound.txt, because I just told you what it is. So you'll be able to guess what that looks like based on this outlier output.txt. All right, moving on. Last, if we're planning on modeling out scrub volumes later, most of the subjects for the OpenFMRI data actually don't have any. But it's nice to put an empty file for those who don't have, let me back up. It won't generate this confound.txt file if there were no volumes to be removed. So this is just creating a placeholder. It's like a dummy file with nothing in it. And that will make scripting our first level analyses easier because we want to unify it across all runs, whether or not they had confounds. So this will fill in the blank. Very, very last. Again, this changes according to, come to a group decision with the people you're working with. Depending on how many volumes you scrub, you might decide, oh, that's too many. I need to omit the subject now because too much has been removed. Then you can set this to do that. So I decided that if they had more than 45 volumes scrubbed, it's going to dump their bold path into a text file. So for the OpenFMRI data I'm using, nobody hit this threshold. They're healthy adults, so there isn't a lot of motion. So you can play around with this on your own and get it to work. I tested it, it should work. And then it'll just create a text file with the bad subjects, and you can use that in the future. You might actually want to change this, though it outputs a file of the good subjects. That might be more useful for you. I don't know. Or you could create it I have no idea. You can do whatever you want to make coding your higher levels easier. Last but not least, let's look at the output. The QA step looks like this. So this is nice. All of the subjects are in here. This is the bold motion QA script or file that's created. And it's nice because you don't have to open and close, how many did I say, 60 files. You can just scroll through this. That's why I did it. And I should thank the great Jenny Pacheco for this trick. She gave this to me years ago, and I think it's so helpful. Okay, this first part is the output. So I'm going to flip back real quick. So this first part corresponds to this part, the outlier output.txt. So the output from FSL motion outliers, I dumped it into a text file. This is that information. So it's telling me what I did, what the out file was, if I need anything deleted, mask, and then the threshold is printed here. Yes, we use 0.9, and it says the metric was FD. Now, if you have scrub volumes, it will tell you how many. And then here's the FD plot. Looks beautiful. Very far from 0.9. So you want to go through this and just look for things. Like this could be bad, but it's not that bad. And this looks like it could be, this is kind of borderline bad, but it was sub-threshold, so it wasn't caught. Okay, scrolling quickly as I can to look for somebody that actually had something scrubbed. Weird. Okay. 0.3, 0.6. Goodness, should have cheated and had a separate window with this open. Ah, wow. 1. See, it'll say found spikes at 125. So that means their confound file, going back to the script really quick, this, where are we? Confound.txt file, they have one outlier, so it'll have a single column of zeros with a single one at the 125th TR. There's a subject that had two here. This subject will have two columns in their confound file. All zeros in the first except for a 1 at TR 107, and likewise, but a 1 at TR 108 for the second one. Okay, so that's what that's why I said you don't need to look at the confound files. You can tell from here what they look like. Everybody else will have an empty one. All right. That's it. Again, prepare your onset files so you're ready and run this script. And again, take your time and play, try to break it, try to come up with a better way. If you come up with a better way than me, let me know so I can change it. So thank you. Please join the Facebook group or follow on Tumblr or follow on Twitter or all three. Next time, I think I will have a video that goes over the FD, DVARs, and this whole scrubbing thing. All right, you guys have a good day.